Yeah, so we have seen some serious applications, but I'm a person who likes deranged stuff, especially in the first talk by Andrew. I think he mentioned something like he is also in a very unhinged applications. So that's something that I particularly enjoy. And also, so particularly I would demo to unhinged or deranged TE applications and also try to abstract from there. So of course, thinking from first principles, what type of applications that TEs enable, right? First, we saw from the first presentation, we saw that maybe using forgetting of information on instructing, you can implement these negotiating bots, so such as facilitated by LLMs using that utilizes this very special property. In game theory, it's called gate conditional recall. That essentially means that human beings, after I see something, I cannot forget that information. However, with SGX and with the botnet, you can try to forget that. Second one, of course, computation over shared private state and non-communication. And however, derived from those, what can we do? First of all, we can put all Web2 accounts onto Web3 rails. What we are doing is that we are bringing all of those, composability, programmability, permissionlessness of Web3, those nice properties, onto all Web2 accounts. So it essentially allows you to make these things, if you guys are familiar with cryptography, called one-time programs for your access. But completely what this means for a user is that, as a user, you run less authorization, but receive more value. And I want to note that this work was inspired by the previous work. And relevant being delegate T, which is located by a lot of our, I think, friends at the IC3. And of course, Phil, that was once, also gave this amazing talk at that time on dark clouds. It was one of the very influential users using PEs as well. And of course, Tom Fry was, it's essentially like, I think, before all of the multi-party computation, before this one was built using SGX. Essentially, you initialize the TLS connection from within the envelope, and therefore try to do some data. But I want to also stress some of the difference between using TEs for this Web2 integration and the multi-party computation TLS-based approach. The biggest difference in my mind is like a lot of the TLS approach only focus on reading data from the website and doing incredibly on-chain. However, if you have a TE, what you can enable is critical writes to Web2. So traditionally, what we think, for example, on the chain is that you have like an oracle, right? Oracle means that Web2 has some data and some you take that data as true. But then, what's the opposite of an oracle? It's like a prophecy, right? It's like you say something and then it becomes true. So I think prophecy kind of nicely captures the difference between the TE approach to TLS connections and the multi-party computation or TLS notary approach to things, right? So with TEs, we are not just mere mortals listening to gods giving us oracle. We become our own gods and become our prophets and pushing things out to the world. And of course, one important priority I think is this is like the original paper of one-time programs, which I think was published in the 1980s. And one of the biggest examples that's used is this thing with emails, right? So using one-time programs, you can implement something that allows you to, for example, you go on vacation and then you want to give your assistant or friend access to controlling your email, but then you don't want that person to have unrestricted access to your email, so you can create those signatures that only allows them to decrypt. You can see that only decrypt and sign emails that are dated for September 2008. Okay, and you have to know TE apps, all of those things that I just talked about, are actually so powerful such that it's against the AI safety policy to discuss it. I personally try to ask those, because I'm a person who likes to brainstorm with AI because I'm autistic. But when I was talking to Cloud about those use cases, I asked, how do you implement programs? It's, actually, again, so, you have to understand the applications and the potential keys are so great such that like OpenAI and Anthropic are like actually think it's at the same existential risk level of seriousness as AI safety. Okay, and then now I'm gonna start the actual demo for those fun applications. I will do some motivation. Okay, so tomorrow modular summit, Mustafa obviously kind of stressed, but then a while ago he tweeted something, wanting the platform where I can anonymously submit banger sheet those ideas to Anon City, which is crypto Twitter accounts that don't want to tweet myself. Now I'm gonna present a platform that does that. Specifically, it does that. It's using TEs, you're able to essentially. So the app is called Teleport, by the way, because you're essentially teleporting into another person's Twitter account. So it
helps. The app is live. If you want, that's he's gonna show it live. But if you want to put your Twitter account in there, you can go to teleport.best right now. Feel free, give it a shot. It's secure, I promise.
Yeah, Ryan is gonna
test it.
Yeah, Ryan is gonna present the attestation for that, and you can try it out. The everything is live on base mainnet using Coinbase wallets. Okay. Yeah. So essentially, it's like the Teleport app is running inside Intel SGX as its continental store database. So we essentially store the user's OAuth token and enforce an access control policy on top of it. And also the composability with Web3 is essentially you can make an NFT that when redeemed allows you to tweet from the other person's account. So let's cut everything and I'm gonna demo it. Okay. So now I think I previously already kind of created a Coinbase account, so I'm gonna let's say something like, okay, so I'm creating my username. Now I'm going to create my first NFT. So over here, what it does is like when I click this, it redirects to my Twitter user page, I think. And then that's the OAuth authorization. So you can see over here, this is.
It happened so fast. What just happened is it redirected. You guys know OAuth, maybe redirected, but it redirected to our SGX machine. It's running on our China. So that machine has the OAuth token, and then it redirected back to front end, which is running.
Yeah.
Amazon
East.
So like this front end never had access, never saw gave to us that user that he just authorized without flow.
Yeah, exactly. And one thing that you don't want when you're giving access to other persons. To your own account, similar to the email example, is that you may not want the other person to tweet racist and stuff or propaganda shitcoin on your accounts, right? You want to set some enforcement policies, but we're in a lucky era because we're born just in time to explore LLM applications rather than just having to hard code every constraint. So over here, when you meet an NFT that represents access, you can have this thing called code safeguard, which is like a policy enforced by the LLM that we basically make the GPT call credibly initiate the TS connection to OpenAI server using the TE. We have tried running LLMs inside TE. The performance isn't great. That's why we didn't do that approach. So over here, I can say something like no racism. Allow any other hosts, and I'm going to link this. Okay, so you can see over here the transaction has been sent to, I think, base supporting. Okay, so over here I linked the account, and then I can, kind of share this NFT with others by copying the invite. Okay, so then I'm opening another anonymous browser to simulate, what would happen if another user just receive my invite. So then now they have the NFT, and then they can make some posts. Maybe you can say something like T ads are so powerful. And then we can redeem the NFT. So what this happens is that we redeem the NFT, it emits an event on base, and then the TE is actually acts as a co-processor. It monitors the event that is emitted by the NFT on base, and then when it sees an event, it fetches the OAuth token from the database, and then does all of the filtering enforced by the LLM call, and then please run the let me hide this from I think it's probably some.
Demo jobs are not working. You got many other demo jobs. It's
It
just
worked
with us.
normally when I did it. So you should probably work on like.
I've been tweeting all week.
Okay. Let me just quickly try another. No. Oh, maybe yeah. Yeah.
Yeah, 1 second.
Yeah. No. Yeah. This is testing.
Okay, so that's
Okay. It's fine. It's probably out of gas. Okay.
on your account.
Oh, okay. Well, yeah. We'll get that back in a minute. But okay. Now I'm gonna display, I guess, another demo that okay, so Mischief Plays Demo is a game for if you guys don't know what this is, it's like
Has anyone played this game? Yes, awesome. You just playing for
yeah, so Mischief is like essentially a creative arts studio in New York, and they create unhinged apps. So what they did is this game called Mischief Plays Demo, where the rule is very simple. Players can pay $10 to join before the start of the game. Prize pool equals multiplied by $10, and then you can eliminate every player every hour. So if you guys play crypto the game, it's also similar to that.
Or
Okay.
just Web 2, it's not on chain. It's just
Yeah, by the way.
crazy Web 2.
Yeah, the cool part of all of this is because none of this is on chain, and that's why you can't create certain pollution strategies by using smart contracts. And the game has certain interesting staking, right? Like 100K is not a small number by any means. Okay, so the difference, what is interesting is that in crypto, you could just create a smart contract to force users to commit to a strategy to compute. You create a DAO, right? However, in Web 2, in this example, users could log in with their password and then divert from the DAO strategy by resetting password. Users also have no reason to trust the centralized entity running the strategy. So we wrote TDX here, but this applies to any TEs. This is just a pure imperfect information game, but with TEs we can enforce users to collude and coordinate. Okay, so now the demo I'm gonna make is essentially called Mischief Plays Demo. But now it's a TE. So now it's that the TE essentially runs a web server that manages a pool of users, and those users get to pick players outside the DAO one by one, and when there are only users inside the DAO, we pick a winner selection strategy. So I'm gonna go.
So the TE wins. The TE votes everybody else off, and then you use all those votes to make sure it wins. He's gonna show you.
Yeah, so this is like Mischief Plays Demo. This is like the game website. So you can see now I've logged into my accounts. I have my full access. But now I should log out, and then because what happens in the TE is that we change its user's password and we simulate the browser exactly the actions of the user such that you can commit but however, for the TE to gain the access to the user's account, we first need to reset the password. So what happens here is that I'm gonna just copy my accounts and then ask the Mischief Web2 server, which we don't have access to send me a link to reset my account password. Okay, great. So reset password, email sent. Now let's see what happens. Okay, great. Yeah, you did it. Okay, so now I can copy the link address to this reset password link, and now you can join proof.code. By the way, this is also live. So if you're playing the game, you can join our L to produce.
Unfortunately, the game is locked. You can't join it now because it's like active. Like it's happening right now. This is
Yeah.
the strategy.
Yeah, so if you're not already registered, okay. So over here to join our WSW, type in your email account. So for me, it's my and then the URL. Right, this is right. Yeah, the URL to change the password, and then I join the DAO. So what happened was so fast, but that means TEs are very performant. Yeah, maybe we need to add some latency for user experience. What happened is
You
that
can also use my CSS skills. Fail.
yeah.
What happens is it spun up a Chrome playwright extension in TE and browse to reset your password, and then has then the access to the actions inside of our Alibaba SGX.
Okay, so now we want to show the attestation process.
Okay, so like we're talking a lot about TEs and like all the things you can do, and then someone asked some questions about like how do you like where's this like root trust? How do you attest these things? Like why does this matter? And so how many people here have actually created a quote or like got a quote from Intel, like using this hardware that we're talking about today? So like maybe like 7, 8, 10 people. And then all those people who raise your hands, have you guys like actually verified those quotes? Okay, because you probably know what that means if you've done it. Okay, so for everybody else, what I want to help you with today, I want to help you understand that process and show you how easy it is today, given the tools that we're talking about. So, get your phones ready. What we have set up is a free subdomain service on ENS. And so we're all today going to create subdomains, and we're going to have Intel sign the subdomain for you that you create. We'll show you how to attest and verify those Intel quotes. So check out this QR code on your phone, and it should open up a site that looks like this. Okay, so this is our little subdomain attestation demo site. So this is using CCIP read off-chain resolution with ENS. And so flash this one more time. It's your last chance to create a free subdomain on mainnet. I'll show you what the root is.
TEE.Salon coming up.
It's wasm.isolated.zone is the. Did it work for you? Okay, so I'm going to create a domain right now. I'm just going to create TEE rocks. This is gasless and it's actually off-chain resolution, so I'm just signing it. Okay, so I just signed that request to create this subdomain. So what just happened in the background, I'm going to show you right now. First of all, let's just go to the ENS manager app, which is a smart contract. It's running on mainnet. And so you can see the resolves. So I just created this subdomain, and then as a text record, this is actually a basic support encoded pressed quote from Intel. And so what does that mean? This record here is the actual material that's like signed by Intel, and what was signed, and how do we verify that? What does that even mean, right? So to do that, we will just use standard Ethereum tools, one of which is we're going to just try to use ENS to resolve that subdomain that I just created. And so I just did TEE rocks. So I'm just asking the mainnet registry to resolve that subdomain, and it reverts and tells the client to check that gateway. And so you can see here, this is actually a quote signed by Intel's root of trust. And inside that quote, I have this EOA address. So this is actually the identity of the enclave that created the subdomain for you for free, and it's signed by Intel. So one way to verify that is just asking. So OpenSSL is going to try to parse that chain of trust. You can see it resolves up to
You can see this resolved up to the Intel root CA, like that root of trust signed the material that was running in Alibaba Beijing that created the record for you. But this is all like, this is terminal stuff. I don't want terminal stuff. This is like not usable by humans. And so if you go to the website that we created to showcase this demo, also has a nice little, how do you verify that? Like, when Flashbox runs stuff and they're saying we're running a TE, you should be like, how do I verify that? How do I know you're doing what you say you're doing? Well, luckily, we've got this cool tool that we have. So if anyone has a quote from Intel, you can actually verify that quote. And one way to do that is to take, it's a little contrived example, but you can just copy. Did anyone actually create a subdomain? Did it work for anybody? Excellent. So you could actually just copy the text record here. You can paste it in this little box. That's CSS. That's actually wrong box. You paste it there, and then if it actually not work.
Generate something that looks like an address, right?
That's the hash of the quote.
Hash of the quote. Okay, well that is the hash of the quote.
That broke. Can that work for anybody? Did anybody try this? Did it
Yeah.
work for you?
Yeah, it would work.
Okay, well, the demo guys are not with us on stage, but the audience is with you, so that's like a twitch demo. So hopefully, for the first time, you're able to actually create a quote or a measurement or an attestation from Intel, which is pretty cool, and actually play with that data. And I know it's kind of, you may not know why our TE created a subdomain for you and why you care about measuring that, but I just want to showcase like these things are like accessible now. They're becoming more accessible. You can create crazy apps like e-built, and then showcase to people how to like use that information. And so this is actually a really cool use case for blockchain and ENS, because how else would we have posted that quote somewhere that's decentralized and with consensus? So we're actually using two systems to provide a lot of trust. So that is a quick demo. Any questions? So those domains are yours now. You can use those domains. You could. It's actually on mainnet, so that's a cool little. That took about a day to build that, so I want you guys to go out and hopefully think about what you can do potentially with this stuff that we're excited about. So that's it.
Yeah.
Woo!